Hi, Bill Bam Bam Woodbury here. And I just thought I'd check in with you. I know you haven't heard from me for a while working on my truck, but that is because my poor transmission, as you can see right there, cannot get the parts in. So I am waiting on the rebuild kit. It's now been pushed back another 2 weeks, so here I wait. On the other hand, I thought to myself, well, during this downtime, do I just wait, maybe play some video games, or do I build something else? Well, you know the answer to that. So I decided to dive deep into a project that's been waiting almost 20 years. Actually, maybe even a little more than 20 years. And that is an industrial air compressor system for my shop. Now, what I mean by that is an air compressor system that can keep up with the volume and pressure needed to run things like sandblasters, grinders, other major industrial equipment. So, a long time ago, a couple decades now, I bought a Quincy 340 compressor head. Now, it needed to be rebuilt, and so it's been sitting with the head off for the last 20 years. And while I'm totally capable of rebuilding it, that is a huge project in and of itself. So last year I started looking around because I'd already collected most of the other parts I needed, and I found this beauty. Now, this is a Kellogg American 241 built in 1976, and it's a double piston air compressor capable of sustaining 29 cubic feet a minute at 175 psi. So that's exactly what I'm looking for. So what I did is I happened to have some old Unistrut laying around from a previous project. I cut that and welded up a frame here. It's Unistrut end-to-end, welded, stitch welded about 80%, with a 1/4 inch steel deck plate on top. Below it I mounted HVAC isolators to help keep this thing from shaking my house. This motor, I picked this up 20 years ago out of the desert. It was on an old piece of mining equipment that was abandoned. So I pulled a couple of these motors and I got one of them to run. It's a 3-phase motor. We'll get into that in a moment. Next, we'll jump to electrical in a minute. So on this air compressor, main air goes in here, comes out here. This leads to this expansion pipe. Expansion pipe has its own gauge, its own overpressure valve. It's set at 200 psi. It branches off, goes through a check valve, and then off to the main tank. The pressure switch is tapped in on the tank side, so we know what the real pressure is. Nice thing is when this thing shuts off, this side depressurizes due to the check valve, which when it goes to turn back on, the compressor isn't fighting 175 psi. It's building from the ground up only on a small point, and then as soon as it reaches pressure, it starts filling the tank, which is pretty quick. So next we go to the electrical panel. Now, when I first put this panel together, I thought, oh, this box is way too big, and then I realized, wow, I needed all this space. The breaker there is a little oversized, really just kind of acts as a 3-phase switch, which is fine, and then a 3-phase 30 amp switch or relay down below. That relay is controlled by this pressure sensor, which is fully adjustable. It turns on and off at 145 psi to 175 psi. So that keeps that tank nice and full. Now in this panel I've also included an additional 12-volt system. It has a little switch, IP67 switch on the side there, and that switch runs to this valve on the back of my aluminum storage tank. Now that valve then runs to this distribution block here, and this way I can keep my tank fully charged when I shut down the system, and only when I energize that main valve does air come out of it. It just helps save on electricity and inconvenience as well. So the next interesting thing is, like I said, this is a 3-phase motor, so I have to run it to a phase converter. So I come in here, and inside my door I've got a little 7.5 horse rotary phase converter that I power this from. So I take 240 volt home power, and I convert it into basically 208 3-phase power to run this. So let's go ahead and see how this looks. So this will build charge for a couple of minutes here. Let's go ahead and just turn this off. See how that runs. So this produces 175 psi. I've got about 200 gallons of compressed air, and fully functional. The only thing I'm going to be doing in the future here, let me turn this off, is this control box is going to include a delay timer relay that's going to then send a circuit, a signal back to the phase converter, so that the phase converter will be turned on when the pressure switch determines, and then like 6 seconds later it'll start this up, because you have to start one and you have to start them in order. So this will do it all automatically, so I no longer have to run the phase converter, power it up, turn the phase converter off. That's a pain in the butt. So it really just needs to be an automatic system. So as soon as I get some amperage readings off the panel that include this running plus the phase converter, I know what size relay to buy to go inside the phase converter, and I can modify that. But anyways, this is Bill Woodbury. Just more tinkering and building stuff, so stay tuned. Thanks.